Good morning everyone. Today we are going to start a new chapter, Matrices. In this chapter exactly what we are going to discuss. Firstly, definition of matrix. Second, order of matrix. Third, elements of matrix. Fourth, types of matrix. Then transpose of matrix and then inverse of matrix. So let's start with the definition of matrix. What are the matrix? So matrix is a rectangular arrangement of numbers and functions which are arranged by a fixed number of rows and columns and enclosed in a bracket. That means every matrix is represented by the bracket this or this. Any matrix is represented by capital letter of alphabet and the number of elements lying in the matrix is represented by small letters. Suppose we have A is the matrix. It has n number of rows and n number of columns. So the matrix is written as into the rectangular format and the first element of this matrix is denoted by A11 where 1 represent row and second one represent column. Similarly, second element of first row is 1, 2. That means the element A12 belongs to first row and second column. The horizontal lines known as rows and the vertical lines known as columns. And so on. We have n number of columns. So the last element first represent number of row. So this is first row and n represent column. Similarly, position of second row, first column element. This is 2, 1. 2 represent second row and 1 represent first column. Similarly, A2, 2 and so on, A2, N. Second row and nth column. If we proceed this, the last row we get the position A. Last row is M. So M1, A, M2 and so on. Last element represented by A, M, N where M is a row and N is a column. Got it? And please be noted if we write M cross N in the last of matrices. So this represents order of any matrices. This is M cross N. Doesn't called M into N. M into N represent the number of elements. So number of elements is represented by NA. This is multiplication. That means M into N. So M into N is a number of elements for any matrix. And the order of matrix is defined by M cross N. This is cross in case of order of matrix and this is into or multiply in case of total number of elements lie in the matrix. Just take another example. Suppose we have M equals to 2 and N equals to 2. That means a matrix having 2 rows and 2 columns. 1, 2, 3, 4. So there are total 4 entries. So the number of elements, this is M into N. Into means 2 into 2, that means 4. There are 4 elements lie in the matrix. The entry is known as elements of matrix. And the position of first element is A11. That means first row and first column. And second is A12 first row and second column. Similarly, A21 and A22. And order of matrix is defined by m cross n. That means number of rows is 2 and number of column is 2. This is R into C or m into n. This. So here the number of elements is 4. That means number of total elements in this matrix is 4 and order of element is 2 cross 2. So we can represent any matrix as Aij. We can represent a matrix A in this way also, bracket Aij, where I represent the position of rows and J represent the position of columns. Then types of matrices. Here we have 10 types of matrices. First is row matrix. By the name of this, we identify the matrix having only row. That means if any matrix having only row, that means this is called row matrix. And here the number of rows is fixed, but there are multiple number of columns. So this is 1 cross n. Rows is always fixed equals to 1, but column is variable, maybe 1, 2, 3, 4 and so on up to n. This is a row matrix. So a matrix which have only one row known as row matrix. And second one is column matrix. So by the name of column matrix, we identify that column matrix possesses only one column and multiple number of rows. Like there are only one column and multiple number of rows. Maybe 1, 2, 3, 4 and so on n rows. So the order of this column matrix is defined by number of rows into column into 1. Next, rectangular matrix. Rectangular matrix is represented by format of rectangular arrangement. That means m cross n. If m equals to n. If m equals to n, that means number of rows equals to number of column. This is known as square matrix. This is known as square matrix. If m not equals to n, so this is known as rectangular matrix. If we have m is greater than n, that means it is known as vertical rectangular matrix. And if m is less than n, that means horizontal rectangular matrix. Suppose we have m equals to 3 and n equals to 3. That means 1, 2, 3, 4, 5, 6, 7, 8, 9. Here number of rows is 3 and number of columns is 3. That means order of matrix is 3 into 3, m equals to n. That means this is a square matrix. Suppose n is 2. That means number of column is 2, but number of rows is 3. So this is a rectangular matrix. If m is greater than n, If M is greater than N, 3 is greater than 2, this is known as vertical rectangular matrix. That means the geometry of vertical matrix is like this and the geometry of horizontal matrix is like horizontally. Suppose M is 2 and N is 3. So that means M represent rows of the matrix. So 1, 2, 3, 4, 5, 6. These are 2 rows and 3 columns. These are columns. So the arrangement of this matrix is like this and this is like vertically. So that's why it is known as vertical rectangular matrix and this is known as horizontal rectangular matrix. Now the next, diagonal matrix. What are the diagonal matrix? In diagonal matrix, the principal diagonal element having the value and the non-principal diagonal elements is equal to 0. What is the meaning of principal diagonal? If we construct any square matrix of order 3 into 3, that means A, B, C, D, E, F, G, H, I. This is known as principal diagonal. This is known as principal diagonal. If there are any entries in principal diagonal but remaining, that means non-principal elements are 0, this is known as diagonal matrix. Got it? That means if I, J equals to K for any I equals to J but K not equals to 0 and Aij equals to 0 for I not equals to J. That means matrix is known as diagonal matrix. Next, scalar matrix. In scalar matrix, a principal diagonal elements all having the same value. That means all having same value. Any value but all having the same value and the non-principal elements are 0. And next, identity matrix. In identity matrix, principal diagonal entries is equal to 1 and non-principal diagonal elements entries is equal to 0. So, Aij equals to 1. If I equals to j, that means 1, 1, 2, 2 and 3, 3. This represent a 1, 1. This one represent a 2, 2 and this one represent a 3, 3. The entries for principal diagonal is 1 and non-principal elements is equal to 0, known as identity matrix, and it is represented by capital I. Next, null matrix. Null matrix having all entries equal to 0, included principal diagonal and non-principal diagonal also. That means all entries are 0. Then the matrix is known as null matrix and it is represented by capital O. This is equal to 0 and this one is also equal to 0. Next, upper triangular matrix. That means any square matrix Aij is called the upper triangular matrix if Aij equal to 0. If Aij equal to 0 for any I is greater than j. For any I is greater than j. I represent row and j represent column. Suppose we have I equals to 3 and j equals to 2. That means A3, 2. This one is A3, 2. This one is 0. If I is greater than j, all the entries equal to 0. Suppose I is 2. That means for 2, 1 entry is 0. For 2, 1, entry is 0. Suppose this is A, B, C, D, E, F, G, H, I. A, 2, 1. A, 2, 1. That means this is equal to 0. A, 3, 1. I is greater than J. That means this equals to 0. And A, 3, 2. That means I is greater than J. This equal to 0. For this is known as upper triangular matrix. Similarly, for lower triangular matrix, if I is less than J, then all the entries are 0. It is known as lower triangular matrix. The lower triangular matrix is represented by I is less than J. Suppose this is A, B, C, E, F, G, H, I, J. I is less than J. Suppose J is 2 and I is 1. This is 1, 2. So 1, 2 is B. This is equal to 0 for lower triangular matrix. And suppose I is 3. So this is 1 and I is 3. J is 3, I is 2. So 1, 3, that means this equal to 0. 2, 3, that means this equals to 0. This is known as lower triangular matrix. Now come to the next point. Differences of matrices. Suppose we have two matrices. A is A, B, C, D and B is 1, 2, 3, 4. So A minus B equals to A minus 1, B minus 2, C minus 3 and D minus 4. So we subtract both the elements directly by respective elements. For find the difference of two matrices, it is compulsory that both having the same order. Here the number of rows is 2 and number of column is also 2. And this case also 2 cross 2. Equality of matrices. Next topic, equality of matrices. What is the equality of matrices? If A equals to B, that means two matrices are equal, then we directly compare value of elements. Suppose this is 1, 2, 3, 4. So we can say x equals to 1 and y equals to 2. That means x plus y 3. So we directly compare the matrices if both are given to equal matrices.